Hi, so this is the second half of the lesson on confidence intervals. Um, so, in the last lesson, we were talking about confidence intervals for the mean, and we really looked at some of the concepts. Well, now we're going to do the calculations. So, the first confidence interval we're going to look at is the confidence interval for the mean. There are actually two confidence intervals for the mean. One of them is used when the population standard deviation is known. That's the Z confidence interval for the mean. Um, all right, so here's our first example. And I'll let you read this, but basically, we want to do a 95% confidence interval for the mean starting salary of all social workers. I want to point out to you here that this says assume the population standard deviation is $3,100. This right here is what makes it a Z confidence interval for the mean, as opposed to the next one we're going to do in just a minute. So we're going to go over to StatCrunch, which I have pulled up already, right here. And we're going to Stat. This is under Z Stats. One sample. And this is with summary, because what we have is they've already done the mean and standard deviation for us. So we just enter the values here, and in the problem it said that the mean was 42,500. It said that the standard deviation was 3,100, and it said the sample size was 50. And what we want is a confidence interval, and it's set at 95%. So we're going to leave it as 95%, and we're going to hit compute. So this gives us our confidence interval. And now to copy and paste this into a Word document, you just literally highlight it, Control C, and then come over to a Word document. And I've got one up, and I'll show you. You just Control V, and there you go. If you do have a hard time getting that posted, though, just do a screenshot and turn it in with your homework. That's fine. All right. So back to the PowerPoint. Our interpretation, and we talked about that before, is that we are 95% confident the mean for the population, in this case that's the mean starting salary of all social workers, is in that interval between 41,640.72 and 43,359.28. If I ask you to give the point estimate and the margin of error, you've got the point estimate here. That's the sample mean, 42,500, and that's plus or minus the margin of error. And if you remember how to calculate the margin of error, we just do the upper limit, so 43,359.26, minus the sample mean, and that'll give us the margin of error. All right, so that's our first example. That's the Z confidence interval for the mean. So again, we're going to use the Z confidence interval when the population standard deviation, that's sigma, is known. Now when you read that as the population standard deviation, not just the standard deviation, because you're going to get confused if you just read that as the standard deviation. The key part there is the population. If sigma is unknown, then we need a slightly different formula, and that's the t distribution. Now, I'm not asking you to do these by hand, but basically it's just a difference in whether you use the z distribution or the t distribution in the calculation. But here's why we do this. So if sigma is unknown, so if we don't know the population standard deviation, we're going to use the sample standard deviation. Now, what we're doing here is we're using a second estimate to generate our estimate. So we're using an estimate of sigma to help generate our estimate of mu. So that means we've got some extra variability. And to account for that extra variability, we need a wider distribution. The wider distribution we use is the t distribution. So that's a little bit of background here. So to use the t interval, just like with the z, we need one or two of these things to be true. Either a large sample size or the data following a normal distribution. Usually you'll just be told to assume that in the problem. So here's an example with a t-distribution. So we want to do a 95% confidence interval for the mean length of all engagements. And so here's what we have: a sample of 16 couples, had a sample mean, of 19.92 weeks of their engagement, and it says the sample standard deviation is 5.73 weeks. The fact that that's a sample standard deviation is what makes this a t-interval and not a z. Okay, so we're looking for the mean, and they give us the sample standard deviation as opposed to the population standard deviation. So let's go over to StatCrunch. And this time we're going to t-stats, one sample, and again we have with summary. The sample mean was 19.92 weeks. The sample standard deviation was 5.73 weeks. The sample size was 16. And we want a confidence interval, and again we want a 95%. So compute, and this is our confidence interval. So again, highlight that, Control C to copy, and paste it over into your Word document. So here's the confidence interval. We got 16.8667 and 22.9733, which means that we're 95% confident that the mean length of all engagements is between those two values. And if we want to try it as a margin of error notation, we'd put the sample mean, 19.92, plus or minus the margin of error, which again we're getting based on the upper confidence limit minus the sample mean. All right, so that's our first example of the t-interval. Let's do one where they give you data instead of summary statistics. On this one, we're calculating a 90% confidence interval for the mean acreage of parks in the city per neighborhood. All right, so go back over to StatCrunch. I've already typed the data in. So we're going to t-stats, one sample, this time with data. We pick our variable, and we got a confidence interval. This one was a 90%, so change that to 90%, and click compute, and that's our confidence interval. All right, so by now you know how to do the interpretation. We're 90% confident that the mean space per neighborhood of parks in the city is between this lower limit and this upper limit. You're going to actually spell out what those values are. And then the margin of error format, that's going to be 15.23 plus or minus, and you just do the upper limit minus the sample mean. Okay, let's do a third confidence interval. This one is not for the mean, it's actually for the proportion. So the population proportion is, the notation is P. The sample proportion is P hat. It's actually a P with a hat on it, I'm not making that up. So P hat is our point estimate for P, just like X bar is our point estimate for mu, and just like S is our point estimate for sigma. So the formula for the sample proportion is X divided by N, where N is the sample size and X is the number of people or whatever units in the sample that has that characteristic that we're measuring. So if we had a sample of 200 people and found that 48 of those people were left-handed, the sample proportion would be 48 divided by 200, or 24%. You can always think of it as X out of N. So 48 out of 200. So if we went over to StatCrunch and we did this example, we want to do a 99% confidence interval for the proportion of all young people who take public transportation to work. That's actually the same data, but I put it in a different context for some reason. We're going to stat, proportion stats, one sample, and we have summary, because they've done the counting for us. The number of successes, that's X, was 48. The number of observations was 200. And we want a confidence interval for P. Pick the 99%. Leave the method. Don't worry about what this method means. Just leave it. Leave it what it is. Hit compute, and this is our confidence interval. And just like you've done before, you just highlight it all, copy it, and paste it into your Word document. So this is our confidence interval, lower limit and upper limit. So we're 99% confident the proportion of all young professionals who take public transportation to work is between this, which is 16.22%, and 31.78%. It's fine with me whether you want to leave it as a decimal or convert it to percents. Just please leave it at 4 decimal places like this. So if you write this as a margin of error, our sample proportion is 0.24 plus or minus the margin of error, and just like before, we get the margin of error by doing the upper limit minus the sample proportion. One question that comes up, and this is an important question, is how do you know when you read a problem which of the 3 formulas to use? Well, here's how you know. The first thing you ask is it for the mean or the proportion? If it's for the proportion, you're going to see words like proportion, rate, percent. The dead giveaway, though, is always that your data can be rephrased as X out of N. Like we had before, 24 out of 200, or 48 out of 200. That would be a confidence interval for the proportion. So you do the confidence interval for the proportion. If it's for the mean, you're either going to be given a list of data, given a mean, standard deviation, and a sample size. And usually you'll see the words mean or average in there. If it's for the mean, then you have to decide, is sigma known? If the population standard deviation is known, then you're going to use the Z interval. And here are some clues from that. Sigma equals, or the population standard deviation is. From previous studies, the standard deviation is known to be, or assumed to be. For those cases, you're going to use the Z interval. Otherwise, you're going to use the T interval. And the way you know that it's the sample standard deviation that's given is it's going to be S equals, or the sample standard deviation is, or this one's a common one you'll see. The mean of the sample is, and they'll give you a number, with a standard deviation of whatever. And the way you read that is that the mean and the standard deviation both are calculated based on the sample. Or, like that example we saw a minute ago, they don't give you a standard deviation at all, but you have to calculate the standard deviation based on a list of data. So, now that we've got that, let's do 3 more examples, one of each, and we'll talk about, as we go, which one's which. So in this first example, we've got the average, so that's another word for the mean. So that's telling you it's going to be a confidence interval for the mean. And it tells you that the population standard deviation is, so that means this one's going to be z. So this one's going to be a z confidence interval for the mean. So I'm going to leave this for you to try. But the important part here that we're focusing on right now is that this is a z confidence interval for the mean because the population standard deviation is given in the problem. This one says calculate a 95% confidence interval for the proportion. So right there, that tells you it's got to be for the proportion. There's really nothing more to say about that one. And for this one, they say in a sample of 40 preteens, the average was 18.9. So that tells you that's a confidence interval for the mean. And the way this is phrased, with a standard deviation of 3.2. So this standard deviation was calculated based on the sample. All right, so that means it's the sample standard deviation is given, so it's going to be a t interval. All right, so that's it for this lesson, and give the problems a try and let me know if you have any questions.